Conic sections, or quadratic relations. Write the name of each conic section, then graph it on the given axes. Example 1. X plus 1 equals negative 1/2 times the quantity y minus 5 squared. First, what kind of conic section is this? When I see only one variable is squared, I know it's a parabola. All of the other conic sections have both variables squared. Second, I have to figure out which way does the parabola open. Usually, we see parabolas of the form y equals positive or negative x squared. The positive opens up, the negative opens down. If it's the other way, where it's x equals the positive or negative of y squared, positive it opens to the right, negative it opens to the left. The positive x direction or the negative x direction. Because this one has x equals and the y is squared, we know it's of this form. And because it's negative, we know it will be opening to the left. Now we have to figure out where to start. Where is the vertex of this parabola? -1, +5. Looking next to the x for the x coordinate, looking next to the y for the y coordinate. So the vertex of my parabola will be at -1, 5. So let's put our x and y axis in a place where it's easy to see this parabola. X, y. So our vertex will be up at -1, 1, 2, 3, 4, 5, right there. How do we get the rest of the points? Well, the 1/2 means that we're shrinking the graph by a factor of 1/2. So normally we think of our parabolas as out 1 from the vertex, 1 squared is 1. But instead, it's a half of that. So a half of 1. Same thing to the other side. If I go out 2, normally 2 squared is 1, 2, 3, 4. But half of that is what I'm going to go. So I'm only going to go 2. Same thing on the other side. Remember that I know which direction I'm going because of that negative y squared. If I were to go out 3, 3 squared is 9, but half of 9 is only 4.5. 1, 2, 3, 4.5. Same thing to the other side. Notice it doesn't matter which side because the parabola is symmetrical. And then we can graph it. Example 2. The quantity x plus 1 squared plus y squared equals 16. I see that both the x variable and the y variable are squared. Therefore, it's either a circle, ellipse, or hyperbola. Because of the plus sign, I know it's either a circle or ellipse. Because it equals a number and not just 1, this will be a circle. It's important to first find the center of the circle. Again, looking next to the x and next to the y for the coordinates of where to start graphing my conic section. -1, 0. So let's draw some axes here on our graph. Knowing my circle starts at -1, 0, well, the center, so we start graphing it there. And then I need the radius. The radius is shown by over here. This is r squared. So if r squared equals 16, r is the square root of that, which is 4. So from the center, I can count out 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. And here is my circle. Example 3. X squared divided by 36 plus the quantity y minus 5 squared divided by 4 equals 1. Again, both the x and the y variables are squared. I have a plus sign, which means either circle or ellipse. And because I have denominators that are different, it's an ellipse. And of course, it equals 1. Just like the circle, it's important to know where to start. Where is the center of this ellipse? So I look next to the x and next to the y for those coordinates. This will be 0, 5. Remember to switch the signs, and if there's no number there, 0 means nothing. So 0, 5. I'm going to place my x-axis low because I'm going to go up 1, 2, 3, 4, 5. There's my center. Now I look under the x and under the y for how far to go out in the x and the y direction. Under the x, I see 36. Often, that's called a squared. So if a squared is 36, that means a, the square root of 36, is 6. So I go out in the x direction, because this is under the x, 6 units. 1, 2, 3, 4, 5, 6 to the right, 1, 2, 3, 4, 5, 6 to the left. Let's look at the y denominator. This would be called the b squared. The b squared is 4, so b, the square root of 4, is 2. So in the y direction, I count 2 units, and now I connect it with a smooth curve like we did for the circle. Example 4. Just like example 3, but here's what's different. Minus. When it's a minus, it can only be one thing, hyperbola. Of course, the x squared and the y have to also be squared. The x and the y must be squared. Notice next to the x and next to the y, similar starting point. We can call it the center. The center is, again, 0, 5. Let's get some axes on this graph. And let's plot our center. Similar to the ellipse, under the x is 36. So a squared is 36. Again, a is 6. Under the y is 4, so b squared is 4, and therefore b is 2. Again, we're going to go out 6 units, 1, 2, 3, 4, 5, 6 in the x direction, 1, 2, 3, 4, 5, 6 to the left, and 2 units up and 2 units down. However, because this is a hyperbola, we're not connecting these with a nice smooth curve. These points are giving us the limits for our asymptotes. So I like to just make a rectangle connecting them because that's the easiest way to do it. And then going from corner of a rectangle to corner, vertex to vertex, and through the center, we connect with dotted lines and then we keep going. This shows us the asymptotes. Do it for the other vertices, and you get both diagonals, extend them, those are the asymptotes. Now we graph the hyperbola. How do I know which points to use? Well, because the x term came first, we go in the x direction. The x direction is to the right and to the left. So from this point, I touch that point and I get really, really close to the asymptote. Touch this point, again, really close to the asymptote. Same thing opening towards the left. And there's our hyperbola.